There are two major reasons why distracted driving is so dangerous. They are inattention blindness and slower reaction and response times. Let me explain. Experts on the human brain tell us that when you try to multitask, you're going to miss things. Inattention blindness is when you don't notice the changing environment. You're looking out the windshield, but you don't actually process everything you're seeing. So you can't properly react to changes in your environment. Your field of vision narrows. Estimates indicate drivers using cell phones look at but fail to see up to 50% of the information in their driving environment. That's like if 10 cars were on the road with you, but 5 of them were invisible. Distracted driving also affects your reaction and response times. When your brain splits resources, your reaction and response times are slower because you're distracted. This is easy to see when you look at total stopping distance. As you might already know, your stopping distance is a combination of perception distance plus reaction distance plus braking distance. Let's see how stopping distance works. You're coming up on an intersection with a crosswalk. The light turns red and pedestrians start to cross. Your brain says, "We need to stop." Perception distance is how far your vehicle goes while your brain is recognizing a reason to stop. How fast it takes your brain to do this can be a little different from person to person, but no matter who you are, it takes longer and you travel farther when you're distracted. If you're being an attentive driver, it usually takes a quarter of a second. At 20 miles per hour, in that tiny amount of time, you move about 8 feet. The next part of the equation is reaction distance. That's how far your vehicle goes while you move your foot to the brake. If you're covering the brake, it takes about 3/4 of a second, assuming you're focused on your driving. That's 22 feet at 20 miles per hour. It takes almost twice that long and twice as far if your foot has to move from the accelerator to the brake. So that's 44 feet at 20 miles per hour. Again, if you're focused. But if you're distracted, perception and reaction distance could both take twice as long or even longer. Can you see how an accident can happen when you're not paying attention? Third, we have braking distance. A lot of things affect braking distance, like the type of vehicle, how much it weighs, how full it is, and how fast you're going. At 20 miles an hour, the braking distance for most cars and light-duty trucks is 19 feet. Braking distance isn't directly affected by being distracted. It's physics. The vehicle takes the same distance to stop once you apply the brakes, regardless of what you're doing. Even so, distracted driving greatly increases your total stopping distance. The difference being distracted makes in the total equation is how soon you apply those brakes. That determines whether you stop where you're supposed to or somewhere in the middle of the intersection. It's the difference between having an accident or preventing one. That's the deal with distracted driving. Taking your mind off your job, even for a second, can lead to tragedy.